Chapter 2, Safety in the Laboratory. We'll go straight to the review questions because this is just the introductory chapters. The first question, number one: what are the major hazards in the laboratory? We first look at the term hazards. What does hazard mean? Hazards are risks or dangers that you can encounter in the laboratory. So, what are the major dangers we face in the laboratory? One of them is infection. We can get infection as we're working in the laboratory. Burns can occur either from pouring of chemicals, accidentally spillage of chemicals, or from fire, from different things. So burns is a major hazard in the laboratory. Cuts and pricks. Cuts are either a sharp object pierce through the skin. Those are cuts and pricks. Needle pricks is an example of that. Electric shock, maybe due to faulty electrical connection. That is a little bit out of our control, but it's also a major hazard in the laboratory. An hazard from toxic chemicals. We have a lot of toxic chemicals in the laboratory, like formaldehyde, and inhaling of these toxic chemicals, they have harmful effects on a person. So these are the hazards that we encounter in the laboratory. So those, I think, are the five major hazards we have in the laboratory. And to the next question, number two: what name some common sources of infection in the laboratory? The common sources of infection in the laboratory, they include nailing of airborne pathogens, call them aerosols. These aerosols, they are released from specimen. For example, when you are centrifuging a specimen, if you did not properly cover that specimen, is going to release these aerosols, these airborne pathogens. And when you inhale that through your nasal cavity or through your nose, you can get infection. Another example of that is when pipetting. When you are pipetting samples or separating samples, you're separating the serum from a centrifuged sample. You can also, there are pathogens that are released into the air, and that pathogen you can inhale it and cause infection to yourself. Also, during opening of specimen bottles, if you open them snappily or sharply, it release a airborne pathogens that can be inhaled. So you have to open them gently. So these are examples of ways where airborne pathogens can be released, and when we inhale them, it's a source of infection. Another example of that is through food or fingers. Injection of pathogens through food or fingers. When we eat in the laboratory, our hands may have touched a infectious agent. So when we eat in the laboratory and put it in our mouth, we are exposing ourselves to infection. Or when we put our fingers into our mouth, in that case. So another way we can get infection in the laboratory is through mouth pipetting. Sometimes there are, when you want to pipette, there are mechanical devices we use for pipetting, but due to many labs not having those mechanical devices, sometimes they pipette with their mouth, which is highly unadvisable. When you pipette with your mouth and try to estimate, you can inhale the chemical or the specimen, because you can't really control it as accurately as a mechanical device. So that is also a source of infection. Another one is through pathogens finding their way into the body through cuts, pricks, or needle stuff. So if you have a injury or a wound or a cut in your body, pathogens can find their way into your body through those openings in the skin. So that's another common source of infection in the laboratory. So I think we have covered the common source of infection in the laboratory. Number three question: what is a medical waste? What does it consist of? Medical waste is a special healthcare waste that may transmit infection. So any waste that we produce in the laboratory that can transmit infection to other people is called a medical waste. These wastes are only produced in the laboratory, and we need to find a proper way to dispose of this waste, because we can't dispose it like ordinary waste, because they will cause infection to other people. So these waste, they include um, blood and blood products. When you want to dispose blood, there's a special way to dispose blood. There's microbiological waste, These are urine, stool, things we do in microbiological lab, pathological waste, these tissues, histology lab. So all these waste you get from there, you have to dispose it in a standard manner. So they are part of medical waste. We have sharp objects like needle. When we collect sample from a patient using a needle, that's sharp object. It should be placed in a sharp container to be disposed of because it's a medical waste and there are procedures for disposing of that. Also, we have disposable equipment like intravenous bag, the where normal saline is kept. Those equipment like that, you have to dispose of them in a particular way because they may transmit infection. So they're part of medical waste. So all these are examples of the five I listed: blood and blood products, microbiological waste, pathological waste, sharp instrument, disposable equipment. All these five, they are part of medical waste. So I think I've answered that question. Number four, what are the general guidelines in the handling of medical waste? The general guideline in the handling of medical waste is what are the steps we take when we're handling medical waste. The way we can talk about it is that for sharp, they are divided into different sectors. For sharps, for example, like needles and the rest, we have sharp containers for them that is puncture proof. So when for the sharps, we keep them in the sharp container and they are disposed either through incineration, decontamination, or so on and so forth. So that guideline, we have to make sure that every sharp is not with normal waste, is in its sharp container and is disposed separately. Why other blood products, microbiological waste, pathological waste in another place, it follows a different procedure for disposal. So those guidelines, we have to follow them. Those are the general guidelines for handling of medical waste. So the guidelines you have to follow them, and that's what the question is asking from us. So number five, what about safety levels? Well, safety levels are levels that are assigned to um, infectious agents based on their potency or virulence or yes violence. So these there are levels assigned by the Central Disease for Control (CDC). So these biosafety levels, there are four of them. We have level one, level two, level three, and level four. Level one is just known microorganisms that does not cause disease in human. If a laboratory is dealing with microorganism that does not cause diseases in human, they have a biosafety level of one, meaning they they mostly do not have a lot of safety protocols um like the rest we're going to come across. Level two is the minimum for any clinical laboratory because they work with microbes that have risks to human health like hepatitis B, salmonella. If you are working with any infectious agents like hepatitis B, salmonella that have risks to human life, the minimum you have to have is level two biosafety. That means those includes lab coats, gloves, physical barriers against these infectious agents. They're in level two. Level three is for is required for laboratory that work with agents that cause serious or fatal diseases. So if a laboratory works with as a test that works with serious or fatal diseases, they need to be in level three of safety level. These diseases they include um, mycobacterium tuberculosis, that's the infectious agent for tuberculosis, HIV, and so on and so forth. So if you are working with this infectious agent, you have to have the minimum level of biosafety level 3. We also have biosafety level 4. This is the highest one and is usually found in reference or research laboratory that work with agents that have very high risks of life-threatening illness to individuals. Only a few viruses are in this level, like Ebola and so on. So that is the final level of biosafety, and that is level 4. So we go to the next question. Next question is number 6. What is meant by universal precaution? Universal precaution is a term that is used to address how um, the safety of laboratory personnel. So it was formed in I think 1958 thereabout by the CDC and NIH, Central Disease Control, and the National Institute of Health. They placed a guideline for working with infectious agents, and this guideline is to help to protect laboratory personnel. The approach is that every specimen has to be treated as potentially infectious. So, by treating every um, specimen as potentially infectious is called universal precaution. So, any specimen, any blood, any body fluid, any specimen coming into the laboratory, you treat it. This can be infectious because the same sample that is brought for, let's say, a not so serious test like malaria can also be the same sample that is sent to microbiology for HIV, something like that. So every sample that comes to you potentially infectious, and there you have to follow guideline to protect yourself from that specimen. These guidelines are the universal precaution, like wearing of lab coats, wearing of gloves, using safety cabinets, washing your hands. So these guidelines are universal precaution, and it was formed by the Central Disease Control and National Institute of Health around 1950 something. So that for number 6 question, and we have come to the end of chapter 2 question.